Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the question on the board using the ideal gas equation. And the question is as follows. A mixture of CO and CO2 is found to have a density of 1.5 grams per liters at 30 degrees Celsius and 730 millimeter mercury. What is the composition of the mixture? For us to be able to find the composition of the mixture, the first thing we need to find is the molecular mass of the mixture. And to do that, we have to first of all itemize the information given to us in the question. Density has a value of 1.5 grams per liters. Temperature is 30 degrees Celsius, which will convert to Kelvin by adding 273. And this is going to give us 303 Kelvin. Pressure is 730 millimeter mercury. To convert this to atmosphere, we divide by 760. So that was 730 over 760 atmosphere. The molar gas constant is going to be 0.0821. And we are looking for the molecular mass of the mixture. Now, the equation that relates these parameters together is P is equal to nRT over N. This therefore means that if we cross multiply, we have P times N is equal to nRT. And making N the subject, the expression becomes N is equal to nRT over P. When we put in the parameters, or the values of the parameters, we have the following. 1.5 times 0.0821 multiplied by 303 over 730 over 760. Which is the value of the pressure. This is the same thing as 1.5 times 0.0821 times 303. Then this 760 goes up. So that will be times 760 over 730. And when this is solved, the value of N is going to be 38.85. So 38.85 is the molecular mass of the mixture. However, that is not what we're looking for. We are going to find the composition of the mixture. In other words, we want to know how much in percentage of this 38.85 is carbon dioxide, that is CO, and how much of this is carbon dioxide, CO2. So to do that, we're going to make an assumption. Let X be equal to the mole fraction of CO. This therefore means that 1 minus X will be equal to the mole fraction of CO2. Do not forget that the sum of the mole fractions of all the components of the mixture must be equal to 1. So if X represents the mole fraction of CO, it automatically means that the mole fraction of CO2 will be 1 minus X, because the sum of X and 1 minus X equals 1. So the next thing to do is to multiply the mole fraction of each component by its molar mass, add them together, and equate it to the molecular mass of the mixture. So X times molar mass of CO plus 1 minus X times molar mass of CO2 This will be equal to the molecular mass of the mixture, which is 38.85. The molar mass of CO is 28. So this is X times 28 plus 1 minus X times 44. 44 is the molar mass of CO2. Will be equal to 38.85. So this is 28x plus 44 minus 44x. When 44 is used to open this bracket, will be equal to 38.85. So you collect like terms. 28x minus 44x will be equal to 38.85 minus 44. 44 minus 28, this is going to give us, so this will become minus 16x will be equal to minus 5.15. So x will become minus 5.15 over minus 16. Don't forget that minus divided by minus gives you plus, so they will cancel out. And the value of x here will be 0.3218. If the value of x is 0.3218, it therefore means that 1 minus x will be 1 minus 0.3218, which is going to give us 0.6782. However, we are told to find the composition of the mixture. So we'll have to express the mole fractions in percentage. So, composition of CO2 is equal to mole percent of 1 minus x. That is 0.6782 times 100. And that is going to give us 67.82. And then the composition of CO is going to be the mole percent of x, and that will be 0.3218 times 100, which is equal to 32.18%. So it means that the composition of CO is 32.18% and that of CO2 is 67.82%. Thank you very much for watching, and see you in the next lesson.